Yes, and allow you to see things from my computer. Okay. Well, why not? It was a classwork in the first hour, content of the first hour. Okay, then recorded in the memory of my computer, via which remember at the view saving stage, what should be the name, or say file saving stage in general. In my courses, I can't request the students, well, say, save as, if it is the first saving stage, save as, you know, and then show the address. Well, check whether the address is correct. I have such subfolders to keep classwork files, okay? And then, well, after showing the address in the file saving dialog, write the file name, okay? Write your surname first, you know this, and then ID number, and then your section number to say that you are in section 2. S2 is the acronym to write. If it is a classwork, use this acronym CWB. If it is not the one only, and there will be some other classworks, and then order them, classwork 1, and then write the date of the studying. Today is the 23rd of March, March 23. Remember. Okay. Offset section. Well, in MECH class on offset sectional view, there is an introduction in record 7b. Second part of this video record. Okay. In the content of this week, well, at present, there is one more record. It starts at the beginning here with this ID number 8 in sequence, 7, 8. The first part of this video record is about section line editing. It is about section lining format. And today, the thing in case to do for editing. And the second part of this video record, okay, a complementary part on offset sectional view. Well, here offset sectional view is explained in 7b, but video record 8, you can find some complementary things. Watch it at home. And well, in other video record, to extend your learning outcome on offset sectional views is over here. It is ID number is 9. Offset sectional view. Well, here the thing to highlight for offset sectioning. Well, it is done in this video record, as I remember. But here, why not quickly make a demo? But first, remind you on my recommendation, what I said. If the sectional view is to create, is a profile sectional view, okay? Show the cutting plane line on the front view, not on the top view. Otherwise, this means you selected the long way. You're going to find the sectional view on, well, here, remember, well, this file at the beginning, well, for this object, I said, okay, show the cutting plane line, not on the top view, but on the front view. By mistake, if you show the cutting plane line on the top view, although your purpose is to create the profile sectional view, then this means first you're going to have the image at the wrong place and then break the link and then move it and then rotate it and then link it again. You start losing time in the order of 5 minutes. Of course, if you know the things to do, it is a little bit tricky. But if you show the cutting plane line on the front view for outputting sectional profile view, then it is quite straightforward. There is no difficulty. Okay, I said. This is classwork 1. Did I save it? No, I save it saying classwork 1, although it was the second. I'm going to correct it later, but here, okay, save this file saying classwork 1. Save as in the memory. Yeah, first rename this to say classwork 2. Okay, and then that one say classwork 1. Okay. But here, for this object, say that we need to show the things at this cross section and also at that cross section. So, well, to be able to make it reasonable, okay, to show this part as if visible, then I'm going to edit it. Well, add a prismatic empty space. Take a sketch right on the surface and then create a rectangle here around this hole. Okay, I'm going to position this rectangle with respect to the center of this drill. So I'm going to apply projection process for having the projection of this, the edge of this hole, and then relatively dimensional constraint, the distance from this boundary of this sketch to the center of this circle, say that is 16. Distance from here to the center is the same, say 16. Okay. Well, from here to there, distance is, let's say 14. Okay, and say that it is symmetric. This is 28. Finish this sketch and then apply extrude. By the way, here, can you see, since the simulated, say, light source, well, here in Inventor, there is a light source. Well, selecting view option and then, well, here dropping this list, you can change the type of the simulation. Saying one light, two lights, the selected one is two lights. There's a light simulation in the environment. Now, for the emitted beams of the light, the reflection angle, okay, angle reflected from this surface and the angle reflected from that surface in this orientation are the same. So although there are two different surfaces here and there, you see it is quite misleading. Without bringing the cursor onto the surface, I cannot distinguish there are two or more surfaces at different levels. It is as if those were the same surface. So, you know, at this point, my recommendation, do not use this visualization style. Select View tab and Visual Style option, drop the list and select not shaded, not realistic. Shaded is in the default configuration, the automatically selected one. Select shaded with aids. Then, well, start seeing thin boundary lines, on the surfaces of the solid model. So much more easily can see that these are different surfaces. Okay. Well, apply extrusion process, showing this region, okay, for cutting the material, cutting the object, how many millimeters? Let's say 10 millimeters. Okay. Now, because of the existence of that empty space, we need to show this cross-section, show the image of the object at this cross-section as if cut, visible. And you see here, this part of the object, it is just this central part, we have a hidden feature, empty space. Need to show the image of this part as if visible because there are some dimensions to show on the view. We need to show the dimension of this cavity. We need to show the dimension of the other cavity. Okay, so well, since this cavity and that cavity are at different cross sections, we need to use an offset cutting plane. I'm going to save this file in the memory of my computer with a different name. Okay, show the address. Section 2 classwork. Okay, and then generate the file name, surname, ID number, section number, CWV123, I think, yes, March 23. Okay, and then, well, I'm going to create the views. Well, in doing this, well, fix, that is the front side, that is the top side. Okay, and my purpose is to show the sectional profile view as if it were cut. Okay, start. I selected the quadrant, say first quadrant, metric you selected means you selected the first quadrant. ISO template is the correct template option. That is the paper simulation, and start the view creation process. Well, my purpose is to create the front view as sectional, left side view as sectional, but the top side as normally created. So, well, using the viewing cube, I oriented the model in the space, so I had it as top side as I required in the correct orientation. This is going to be the normally created view. So first start button is okay. Scale factor 1 to 2 is quite good relative to the size of the paper for this order of magnitude, and then say okay. And then cutting plane definition. Start sectioning process. And then, well, for the front view, I can use a flat cutting plane. Well, indicate this view as the reference view to say that cutting plane is perpendicularly oriented with respect to the plane of this image. And then, well, since it's a symmetric object, well, define the cutting plane as located at the plane of symmetry. So, well, bring the cursor to the vicinity of this characteristic point. It is the midpoint of this edge, and it is at the plane of symmetry cross section. Well, see the green dot, but don't click. Move the cursor away, keeping the dotted line, and then after reaching to this location 10 millimeters away, click. Move the cursor in the opposite direction, 10 millimeters away, click. Right-click the mouse, and then say continue. Well, create the sectional front view. At this point, well, let me bring the wallpaper of my presentation to the screen. You know, on the wallpaper for the same object, what we have the sectional front view. On the sectional front view, I think you perceived, well, this part of the projection, there is no cross-hatching line, that part as well. Is it by mistake? No, it is not. There is another outcome to gain at the complementary part of this chapter. Its title is sectioning, sectional views. Not today, but next meeting of this week, okay, meeting time, I'm going to start to explain the reason why on this view there is no this part cross-hatching line. But here at this stage, the created view, well, since you don't know the details, such a deeper detail, but assume that although this is a wrongly created image, as if correct. Say that front view is okay. Yes, here I said that. Well, actually, by mistake, I think I closed the file. try to bring it to the screen. Classwork. Well, section. Wow, this is the wrong folder. Sorry. Yeah, correct folder. Semester folder. Section 2 folder. Classwork folder. And which view I want to bring? This view. Where it is, yeah. What? Do it again. Well, I'm using double display, so well, it is in the other display. Okay. Well, here, okay, in the folder, making it is size larger. I mean, say here, you know, in the first classwork, I said that, well, no problem. Show the cutting plane line on the front view for outputting this sectional left side view. Is it possible to say the same thing here? My purpose is to create the sectional left side view. But it is not to show the things at the cross section, that cross section, the same cross section. I need to show the things as if visible at different cross. These are at different cross section. I need to show this part as visible. I need to that part as visible. You see? Well, there is an offset between this cross section and that. So no need, say no doubt, I need to use an offset cutting plane. Think about it. How can I show the cutting plane line, offset cutting plane line, the edge of the offset cutting plane on the front view? Impossible. Because on the front view, I cannot see the edge of offset cutting plane. It can be shown only on the top view. So, well, this means in case not to use flat cutting plane, but to use in using offset cutting plane, it is the plane to output a sectional profile view. It is unavoidable. We must select the long way. Well, you know, in the long way, the things to do, thanks to the classwork studying, say, and also today I repeat it again, well, quickly, or the first week of the semester. Well, unfortunately here, in such a case, I need to use an offset cutting plane and I must follow the long way. See the long way. Start view creation process, sectional view creation process, and then I must indicate not the front view to say that cutting plane perpendicular, but the top view. Move the cursor to the vicinity of the top view, and then after seeing the dotted frame around it, make a click. I said that cutting plane is perpendicular to the picture plane of this view. And then my purpose is to have a segment at the symmetric cross section of this part. So brought the cursor to the characteristic, to the vicinity of the characteristic point of this segment, and then keeping the dotted line between that characteristic point and my cursor, reach to this point. It is sufficiently away from the outmost boundary, click. And then move the cursor here. Well, I should have a corner at this point, but, well, you see, there is no characteristic point to snap here. By mistake, I may exceed the limit, symmetric cross section, or may not reach to the symmetric cross section. What can I do? Well, here I know at the symmetric cross section, for instance, there is such a characteristic point, or there is such a characteristic point, or the midpoint of this arc. Bring the cursor to be able to guarantee to have the corner in alignment with the characteristic points. These are at the symmetric cross section at which I need to cut the body. So while keeping the dotted line between the cursor and that characteristic point, turn back to here. And after seeing parallelism symbol, relative to a parallel line, or perpendicular to symbol relative to another boundary, it is perpendicular to the edge of the segment, then yes, I am sure this point is in alignment with the characteristic point. It is at the symmetric cross section, and it is the cross section to have the offset here. Could you understand the thing to do? And then make a click to say that there is a corner here. And then move the cursor to the vicinity of the other corner point at which the direction for this cutting plane line is to be changed. It is in this example the center point of the core, this drill, for instance, green dot. Well, I need to change the direction here, click, and then move the cursor in the vertical direction, reach to the outside. Well, I define the cutting plane, and that's it is edge. Okay, edge view. Continue, right click and then say continue, and you know, it is the first stage in the long way. Can create the sectional view over here. And there is no picture plane, okay, to have any view over there. So I must move this view from this wrong place to the correct place. Okay. You know how. Clicked on break alignment option here. Indicate the created view first and then the reference view. This is to break the link, and then move it by dragging to the correct place. It was in alignment with the consistent with the top view here, but when I moved it to there, then yes, cannot be consistent with the front view. It must be consistent. So if I rotate it, in which direction? In the counterclockwise direction, it is going to be well consistent with the front view. I know this. So indicate this view with a click, right click the mouse and select rotation option with a click, and then we'll select the correct button. It is this one to say that counterclockwise direction rotated. Okay, about what, say, using an absolute angle, it is my method, into this box, right, 90 degrees. Now, I corrected it is orientation, but it is still floating, you see, not linked, not connected. Then, well, set the alignment, select, since this and that are to be in the horizontal direction alignment, select horizontal alignment option, and then indicate this view, indicate the reference view. Yes, the end of the long way. The views are now consistent. Balance them on the view. And then, well, the mistake. You see, here, well, one more time to explain what is wrong. Indicate this view. Well, sorry. Start sectioning, say start projection process. Indicate this view and then move the cursor in the diagonal direction to allow you to see this photograph, pictorial figure. Yes, well, that is the remaining part to visualize. Okay, it is just used at the background, okay, for creating this offset sectional view. It is the remaining part. Or one more time indicated and then say, you see here or there. Yes, this is, I think, more understandable. Created here. Yes, that is the remaining part. If we cut the body using this offset cutting plane and remove the obstacle, okay, then we have this remaining part. Okay, the rays of sight to be sent by the observer for this remaining part is in this direction. Okay. Yes. Now here you see inventor did the same thing. Well, although this surface is not a real surface, okay, not exist in the design of this object, it is just an offset surface, okay, it is edges over there. As if it were a real surface, you see inventor created this full line, this thick line. It is absolutely wrong. And one more thing here, just here, this cutting plane, you see, cut this triangular prism at that level, and as if this intersection is real, you see inventor created one more thick line there. These are to be edited. That view is to be edited. Well, how? There is no visible boundary here. It is just, well, result of this imaginary cutting, a created intersection here, this intersection line. Can you see this intersection? But since this cutting is not real, that intersection line shouldn't be shown using full line quality. Highlight that it is just an imaginary, say, it is a surface, the boundary of a surface, it is just an imaginary surface. Well, that is the method under agreement. Decrease its thickness. Bring the cursor to the vicinity of this visible line. Left click, right click, and select from the menu. It will appear after right clicking. Properties option. And in the property dialog box, select the thin line thickness, 0.2. And then say OK. Now this is to highlight that there is no real surface here. What can I do for this thick line? Well, here, this part, there is a hole, and half of the hole you see is here, this hole. It has longitudinal axis, so well, this part of this thick line can be replaced with how? Left click, right click, and property option. Okay, and then from the list, select chain line option, but axis of symmetry is not a chain line. Chain line is a thick line, you know, footnote marker, you know, the alphabet of the language. After selecting chain line to have long dash, short dash, select the thickness of center line, 0.2, and then say OK. Yes, here have long dash, short dash. Okay, for this part as well. Or, well, since you see, well, there is one more segment here to repeat the same thing. Well, say that, oops, and then I may follow this way. Take the visibility of this wrongly created thick lines. Okay. And then, well, actually, I made the wrong click, sorry. Well, take the visibility of this part. Okay. But not that one. Okay, well, there is a difficulty here because I want to keep this part of the line, but over there I want to have the longitudinal axis. Well, since this emboss is symmetric, if I indicate this limit, indicate that limit, I can have the longitudinal axis at the correct place. If there were no such a symmetric emboss at the top to indicate the limits for having the longitudinal axis, I will do such a thing. You know this technique. Edit view, although hidden lines are not used on sectional view, well, remove this marker. It prevents us from selecting the style button. Select the style button and then say OK. After, for a while, having the images of the hidden lines, then, well, add the longitudinal axis by showing, well, the limit of the hole here and there. It is to have this necessary line. And then don't forget to remove the hidden lines. One more time, edit. Select this intermediate button. Well, the symmetry axis is okay. How about this line? This line is to be shown, well, not in thin quality because, well, that surface is not a real surface. Replace it with a thin line. But here, when I deleted the other full line, I lost this part of this this line. So can do what? Well, these are tricky further details. Well, if you want, you may also, well, instead of dealing with the property changing, thickness changing, well, okay, then similarly hide it. And then, well, indicate this view to be able to add the necessary thin line. There should be a thin boundary line between this part and the other part. It is to say that these are not at the same cross section. You see, this part of the sectional view is at this cross section, the rest is at different cross section. There must be, it must be shown, there must be a boundary line, but that boundary line shouldn't be visible line in the quality of visible line. It must be thin line like this. Well, here, to be able to have such a line, boundary line, I recommend, this is in general always applicable, indicate the view first with a click, don't forget. And then, well, along the Place Views ribbon, find Start Sketch button. It is the thing to do to take the created views in sketch mode. And then, well, using the sketch technique, from here to there, draw a line. But in drawing the line, yes, I know that from this list, I need to select straight line option, start the process, but you see, although I am sure that that straight line is to start from this characteristic point, midpoint of this boundary, but it is not selectable. Couldn't find the green dot. Why? Because there is one more trick. If you took a created view in sketch mode and need to snap, indicate some characteristic points on the view, and also need to take a right to put some dimensional constraints, then, well, this is a must. Click on Project Geometry button, okay, and have the projection of the projection. For being safe to site, have the projection of all using windowing method. Well, after having the projection, you see the boundaries of the projection are in highlighting. So, well, thereafter start the line creation process, and yes, you see it, there's a green dot. You can snap it as midpoint. Snap it, and then snap this one. Okay? This point. Or you can extend it to here. Okay? If you couldn't find a characteristic point to end this line, okay, you may arbitrarily create it as if inclined. Press escape button and geometrical constraint. Either snap the other point and trim the rest, or create it like this with such a further extension. Okay, and then correct its orientation. It must be vertical. Click on vertical, the constraining tab, and indicate this line. Now it is perfectly vertical. And start the trimming process. Trim this further extension. Yeah, yes. And then finish sketching stage. That is good. You see, its thickness is correct and it is at the correct place. The rest is axis of symmetry. Okay? Well, of course, don't forget to show. I hope my delivery became okay. Well, someone is following me. Sorry. Clicked on this button and then, well, show the longitudinal axis of this part, but don't extend this axis of symmetry because this part, you know, is not a revolved feature. It is a rectangular space, prismatic space. For the rectangular spaces, or rectangular features, we do not define the longitudinal axis. Okay, and then the rest of cones, well, here on this view, show this, show that, have the longitudinal axis, show this, show that longitudinal axis, and this is a revolved feature, longitudinal axis, and then show the dimensions, etc. I'm going to skip that stage. Well, delete this pictorial figures without forgetting. Right click, delete, yes. Left click, right click, select delete option, delete, yes. Orthographic views only. Okay, classwork 4, I think, can save as classwork 4. Great.
Yeah, I have a question.
Yes.
Can we use to draw? That can we have offset sectional view on frontal pixel plane?
On the front view?
Yeah.
No, impossible. You cannot define the cutting plane because, well, how can you see that cross section to say that cutting plane is in Z shape? Its edge cannot be shown here. Well, here, clarify, bringing this this example from my presentation. For instance, here, can you see? Take a pointer. For instance, this cutting plane, it is flat. So, well, observing the things in this direction, you can see the edge of cutting plane. Well, like this on the top view, or, well, observe it in this direction. Since it is flat, you can either show the edge of cutting plane, well, this edge, or that edge on the other side image. But if it is in Z shape, like this, then, well, observing it in this direction, you cannot show this edge and the other edge. Well, it is only applicable or can be indicated to its edge on the top view, or cannot show it on the front view. So that long way is unavoidable. Okay, well, dear students, the part of the video record in MECH class, well, here where it is written, this video is about section line editing. Well, to be able to make this clear enough, what I mean saying editing, first, let me use this slide of my presentation. Actually, over there in that video record, you can see it. Okay. Well, say that on a sectional view, that is the area. It is to be cross-hatched for highlighting that the image is sectional view, and say it is the solid part cut by the cutting plane. Okay, take a pointer. And then you see, for this case, it is said, good practice, correct. This is incorrect. Why? Well, say that this is the solid, the surface of the solid part. It is to be shown on the sectional view as cross-hatched. Well, to be able to make the highlighting that it is a sectional view, we use equal spaced inclined lines. Equal space, this means this distance is to be equal to that, this distance equal, this distance equal, equally spaced. Inclined lines. And the line quality, you know, thin line. Well, here in figure D, this is wrong because line thickness is wrong. It is a thick line. This is wrong because of the wrong line thickness. This is wrong. Why? Because the space is not proper, the determinant with respect to the area of the surface. Exaggerate the case, say that you use selected very great space value and had only one cross-hatching line on the sectional view. How you can expect that the reader would distinguish such a line, you have only one, and would say that it is a sectional view. Relative to the area of the surface, be able to select a suitable space value. For this order of magnitude, this is good, 2 millimeters in this order. Well, before and in hand drafting, it might be the case of a beginner. In drawing the section lines, you see, student couldn't keep the space value the same. You see, not the same. These are not equal space. Another mistake, you see, student couldn't stop the pencil point at the boundary and had, by mistake, such further extensions. Beyond this limit, there is no solid surface. So, well, section lines shouldn't be extended, hadn't to be extended. Today, in Inventor, this case is out of question. Inventor never makes such a mistake. In creating the sectional views, Inventor ends the hatching lines at the boundaries of the surface, no doubt. Inventor, if you do not change its configuration at which the section lines are defined as thin lines, never makes such a mistake. But Inventor, even Inventor, if the area to hatch is a very thin but long area, then may not generate a suitable space value. So you may have very rare, few hatching lines. Those may not be sufficient to draw the attention of the reader that it is a sectional view. And also, well, the other thing, well, seldomly it may be the case. Normally, most of the cases, the space value is generated in creating the sectional views for the hatching lines very suitably by the software on behalf of us, and it is applied. But if the surface to hatch is slender surface, then yes, well, you may need to edit the cross-hatching lines. And Inventor, although it's a new generation and very capable software, cannot control whether the hatching lines are parallel or here perpendicular to the boundaries of the surface. It is not controlled. So, well, if the hatching lines are parallel or perpendicular, we say poor practice. Change the angle. After this introduction to see how. Okay. On the already created view, answer the question. For instance, say that the hatching lines are perpendicular or the space value is not proper. What can you do? If it is necessary, then how you can edit the section lines? Actually, it is subjected in the first part of this video record, section line editing. Bring the cursor onto the cross-hatched area. After seeing this highlighting, left click, right click, and select edit option, not hatch style option, edit option. Have this dialog box. If you need to change the inclination angle, here is the box to write the new angle, not 45, for instance, 60. Never write the angle as equal to 90. It is going to be perpendicular to this boundary, it is mistake. Parallel to those boundaries, it is mistake. It is wrong. Say that, for instance, 55 degrees. If you have only few hatching lines, for instance, increase this scale factor and say that 30. You see, one hatching line here, it is not so sufficient to highlight that view is sectional. If you couldn't find the space between the hatching lines proper enough, then this is the thing to do. Okay, bring the editing dialog box and then write the suitable scale factor. Clear writing. If your printer or plotter is colorful, then for hatching lines you can select, clicking on this, for instance, green as the color of the hatching lines. But say most of the cases we use black and white. Okay. Yes, this is okay, I think. Well, the other part, well, in my presentation, actually, I have already planned to finish that part as well, is on half sectioning. Yes, half sectional view. Now, kindly ask, well, do we have 15 more minutes to allow me to continue? well, see your face. Stopping sharing. Do we have 15 more minutes, my dear students? If the answer is yes, raise your hand, please. Great. Okay, wonderful. Well, since in section 1 somehow I reached to such an end, that's why I kindly asked you. I couldn't understand why I lost 15 minutes. I repeated the same thing maybe one more time unnecessarily, or became more suitable for you. But say it's a reality. I need to use 15 more minutes. Well, sorry, there is something. I'm in the class, Abdullah Bey. Sorry. Call me later. Call me later. Sorry. And, well, unfortunately, I recorded such a thing. Well, watch the video record and then see that someone just called the teacher. Try to edit that part. Okay. Well, half views. Well, first see, my presentation, this slide. It is an advantageous thing to, pointer, take a pointer. Well, say that in the scenario, you have a very limited working area on the drawing paper, and there is no more space for the left side view or right side view in this example. And you have some things to show at the outer side. Yes?
You're not sharing.
We cannot see your screen.
Oh, well, thank you. Thank you. Well, and show. And then, well, it is, well, really a very valuable notice. You said, yeah, hocam, you forgot to share. Okay. Otherwise, it would be obligatory for me to record one more video film. Okay, now, well, here talk about half sectional views. Half sectional views. Take a pointer, and then in the scenario, say that you have an object. It is pictorially described here. There are some exterior features to have their projections, and also some interior features to have their images as if visible. Why? Because you have some dimensions to show. Okay, most of the cases, okay, it is the reason. But say the paper, working area of the paper is very limited, and there is no more space to add one more view. For instance, left side view. What can you do? Is it allowable or is it possible to show half of the object as if normally created and the other half as sectioned? The answer of this question is yes, if and only if the object on the projection has a symmetry. For symmetric objects, we can show half of the projection as sectioned, other half as unsectioned. Well, you see this object is in full symmetry on its front view. Okay? On the left side view, there is no symmetry, but on the front view, it is symmetric. Well, in creating the sectional view, it is called half sectional view. It is assumed that object halfly is cut. We show the cutting plane as it is seen on this example, like this. At the center, symmetry, center of the symmetry, say object, will have a corner part with the necessary highlighting. And at the other end, avoid using an arrowhead. Only one arrowhead, it corresponds to the observation direction here. It is the sense to send the rays of sight for outputting this view. Only at this end, show the arrowhead. And another thing, you know, on drawing the sectional views, we omit the images of the entities. These are still hidden, even though the process, sectioning process. In this example, you see at this side, there is a step. although we cut the body at this cross section, it is still behind of a certain obstacle. It is still hidden. This is the question. Shall we show the image of that surface on the sectional view? No, the answer is not. Don't show it. Obey to the general agreement. But this half of the projection is unsectional. On this view, show the image of that surface. That is the reason why we have such a dashed line here. It is the projection of this surface in this example on this unsectional half. But here, I know you're going to ask me, change the color of the pen. Okay, take blue. Well, you're going to ask me, yeah, hocam, there is a hole over here. And well, the expected thing, how about the image of this? Since this view is unsectional view, then normal view, then well, had to be such a dashed line here and also there as the other half of the hole on the projection. Here for half sectional views on drawing or creating the image of the part where there is no sectioning, it is a rule. Since the interior feature can be seen looking at the sectional half, we do not show the rest of that entity on the unsectioned part. It is a rule under agreement. Don't show this hidden part. Okay? Yes. These are the things to know, to pay attention. If it is necessary to show the image of such a thing, it is, even though the cutting process still hidden, only for that part have the dashed line, not the images of the other things on the unsectioned part. And since this is under agreement, yes, say that almost say like a standard rule. Okay, now knowing such things, well, see the things to do at the CAD application part. Actually, if you, well, still allow me to use the time, then we'll say that, okay, let us create such a model. But if you say that, yeah, hocam, cannot extend it furtherly, then I may use the model which I created yesterday for the same purpose in section 1. I can bring it from the memory of my computer and then just draw the attention to only the view creation part. Here is the model of the object. I am sure, yeah, well, at home, try to create such a model. Not so difficult. Well, within the cylindrical part, I have a hidden feature. It is needed to show as visible, as if. And well, that is the step. Well, while I'm observing the body in this direction, it is the front side of the body. It is, even though the cutting process still gonna be hidden. Okay, I'm going to use this model for demonstrating the things to do. Okay, view creation, process, start. Okay, and well, orient the paper vertically because there will be in this example front top combination. Select portrait radio button here and then start the view creation process. Which side is top side? In this orientation, well, that's the top side. Try to use 2:1 as the scale. I think I can fit both of them. That is the regularly created view. Okay, and then start the sectioning process. For half sectional view, for offset sectional view, the button to click is the same at the beginning, this facility. And then indicate this view with a click. Say that cutting plane is perpendicular, and then I'm going to cut the body at this cross section. At this cross section, this is one of the characteristic points. Keeping the dotted line, move it to here. Left click, right click. Oh, well, sorry, made a mistake. Click on this button, indicate the view, and then bring it to the vicinity of the characteristic points, and then reach to here, and then click the mouse, and then turn back to here. At the center, make the other click to say that there is a cornering over here. And then move the cursor. Thanks to the symbol, you see perpendicularity symbol is in the vicinity. I am sure this segment of the cutting plane is in the correct orientation. Left click, right click, and then say continue. And then move the cursor in the correct direction. Here it is. And then with the left click, have the image. And then the treatment. Well, this full line is by mistake, you know. Inventor did the same thing. Well, as if what profile surface were real, inventor created it is image. Well, here, this part, well, can be quickly edited because here we need to have the longitudinal axis of the cylindrical part. Bring the cursor to the vicinity of this thick line, this segment, select property option after right clicking, and well, here, yes, select chain line option, and the thickness, don't forget to drop to 0.2, and then say OK. And then yes, great. Here between this sectioned part and that unsectioned part, we have the axis of symmetry. How about the rest? Here the rest, since the base is rectangular prismatic, cannot extend the symmetry axis. Just take it as, change it as type from visible outline, decreasing its thickness to 0.2. Have a thin boundary. It is to say that between this and that, well, there is an offsetting, and there is no real surface to have it as image. That is good. And then, well, you see, this surface is still hidden even though the process, sectioning process. Well, we need to show it on this view. How? Well, bring the cursor to the vicinity of this, left click, edit view. And then, well, if this tick mark exists and prevents you, remove it, and then select the first style button. Have the hidden lines. But yes, this hidden line is a must to have on the view, but the others not. What can you do? Well, this half of the hole on the sectional part is sufficient. No need to show this hidden part. You can only do this. Left clicking indicate, right click and deselect visibility. Indicate this, right click, deselect visibility. Indicate this, right click, deselect visibility, and so on. Right. And well, no need to show this hidden line. Left click, right click, deselect visibility. That is okay now. And then the rest, show the other axis on the top view, for instance. Yes, while this axis, don't forget, must be shown. And then the dimensions, fill in the title block, etc. Okay, that's all for today, my dear students. Thank you.